Hello everybody, welcome to section 12.3. We're going to be talking about surface area and lateral area. Okay, the bases are congruent faces in a parallel plane. So we see this picture here with the base, it's kind of like the top and the bottom. They're always parallel given any kind of polyhedron. Faces that are not bases are called lateral faces. So anything that goes around the figure, the 3D object, that's not one of the bases. So the lateral faces intersect at what we call lateral edges, as we can see here from the diagram. Lateral edges are parallel segments. So notice we also are pointing out the altitude here. It also represents the height of the prism. It is the distance basically from base to base in most prisms. What we have here is a right hexagonal prism. A segment perpendicular to the bases with an endpoint in each plane is called an altitude, like we pointed out. The height of the prism is the length of the altitude. So we always find the altitude, and that'll tell you how high the prism is. A prism with lateral edges that are also altitudes is called a right prism. If the lateral edges are not perpendicular to the bases, it is an oblique prism. So here is what we're talking about, oblique. Notice they're not perpendicular, the lateral edges are not perpendicular to the bases. Lateral area, L, is usually the case in the formula. It's the sum of the areas of the lateral faces. So basically the area of all the surrounding faces, but not the bases of a prism. Okay, the lateral area of a prism says if a right prism has a lateral area of L square units, a height of H units, and each base has a perimeter of P units, then the lateral area equals P times H. So in order to find the lateral area of a prism, find the perimeter of a base, and we just multiply that by the height. Surface area of a prism takes it a step further. If the surface area of a right prism is T square units, its base is H units, and each base has an area of B square units and a perimeter of P units, then T equals L plus 2B. Okay, so the whole surface area is you take the lateral surface area and just add the area of the two bases. So it kind of rounds it out. We're not just finding the lateral area, we find the entire surface area of the prism. Okay, next section, we're going to be focusing on cylinders here. Lateral areas of cylinders. The axis of a cylinder is the segment with endpoints that are centers of the circular bases. If the axis is also an altitude, then the cylinder is called a right cylinder, otherwise it's an oblique cylinder. So we have a right cylinder. There's the base, there's the axis. Axis is sort of what is spun. The cylinder is spun around, it's directly in the middle. And then notice in this right cylinder the altitude is perpendicular with the base. But in the oblique cylinder, the altitude is still perpendicular, but our axis is not perpendicular to the base. It says the net of a cylinder is composed of two congruent circles and a rectangle. The area of this rectangle is the lateral area. The length of the rectangle is the same as the circumference of the base, 2 pi r. So the lateral area of a right cylinder is 2 pi rh. So think of the net, as they note here, is sort of the unfolding of a 3D object or a polyhedron. And it's pointing out here, if we were to sort of slice up the surface area of a cylinder, we'd have this rectangle and two circles for the top and bottom bases. Lateral area of a cylinder. If the right cylinder has lateral area of L square units, a height of H unit, and the bases have a radii of R units, then the lateral surface area L is 2 pi rh. We just take pretty much the circumference of the base, multiply it by the height of the cylinder. Surface area of cylinders is to define the surface area of a cylinder. Let's first find the lateral area, then add the area of the bases. This leads to the formula for the surface area of a right cylinder, which is this right here. Area is 2 pi rh plus 2 pi r squared. So basically this is the lateral surface area, 2 pi rh, and the 2 pi r squared is the area of both bases, which are circles.